So it's a great pleasure to be here today. My first visit to Purdue, and in fact, almost my first visit to Indiana. So, very, very nice to be here. The picture that you're seeing on that top corner there is a picture of Almaden Research Center. For those of you who don't know about it, we're nestled in the hills. This is a very rare picture. It never snows in California. About once every 6 years, we get snow on those hills, and somebody went out there and snapped a photo. But it's still one of my favorite pictures of the lab. What it's doing up there is we're going to talk about beauty and the beast. Beauty being the research world, the world that we all live in and breathe. Perfect, much better. Thank you. And so it's going to represent beauty in this talk. And then at that other right-hand corner there is a picture of our Silicon Valley lab, as they call it today. It used to be known as our Santa Teresa lab. It's actually not a bad-looking facility either, but it is where we do the development of a lot of different products in IBM, and in particular, it's where the information integration line of products got their start. So it's going to represent the real world, or the beast, in this talk. And this talk comes out of my history of my career with IBM. I've done a lot of research in the area of information integration over the years, and then about 8 years ago, I got the opportunity to spend some time in the real world, and I spent about 5 years at Silicon Valley Lab working at what eventually became our information integration business. And so what I want to talk to you about today comes from my experiences there and contrasting the two realities. So I'll carry the Beauty and the Beast theme just a little further. We'll tell the story this way. There'll be a prologue in which I will explain why information integration is important and what some of the challenges are that we've been trying to address in the research world there. And then I'll give you some examples of beautiful results. Frankly, I'm not going to spend a lot of time on the research that's been done, but I will spend a little bit. I'll tell you a little bit of what we know how to do well, and so on. More as stage setting. And then what I really think that I can bring to an academic community is to tell you a little bit about the beast, that is about the real world problem that information integration is, and what it is our customers, the people who are out there really trying to bring information together, have to deal with. And then I will end the talk by trying to speculate on how we could, break the spell, how we could bring beauty and the beast together, how we can have a happy marriage between the two. And that's kind of what I intend to cover today. So information integration is a very hard problem, and in the next few charts I'll go through some of the different challenges that arise and that make it so challenging to deal with. This particular chart is actually a very sentimental one for me. I started using this chart in 1993 when I started working on the Garlic project, and I've used some version of it probably in every talk I've given since. Not quite, but it still does a very nice job of describing one aspect of the integration problem, and the one that particularly concerned me in that project, which is how do we bring together information coming from very diverse sources. We have sources that have their data stored in relational databases. We have sources that are documents, things that are in files, things that are encapsulated by application programs. We have differences in protocols. We have differences in data types. And often we have the same sort of information represented in different ways. We may have just a range of different relational databases. We may have different modalities of information, such as images and so on. And at the heart of the integration problem is the idea that there's a user that somehow needs to bring together information from these different sources, and who typically is not an expert in either the information or the data sources, but who really wants to be able to get an answer to some query. So in this case, it's a doctor who thinks that maybe she would like to, she's looking for other patients who are sort of similar in some dimensions, and yet she wants to see and then she wants to see what they've been treated with. How have we treated them in the past? Very simple, straightforward question for a doctor. It actually, still today, we don't really have a good solution for how to enable doctors to answer these kinds of queries. Okay, so the other question, another issue that I alluded to just then was that a lot of times this information isn't really discrete. It overlaps, and some sources may have complete information about some characteristics. Other sources have very spotty information, but it's very valuable where they do have it. We need to be able to bring that information together and figure out how it fits together. So we have overlapping information that may have different values. We have incomplete information that we have to fill in the gaps on. How are we going to do any of that? So this particular problem is actually one my poor son worked on in the summer, his very first job, and he's in an environmental engineering company, and they're trying to put up a website where you can calculate something like your carbon footprint, and they have a lot of data. They have a bunch of data in spreadsheets coming from all the appliance manufacturers telling you the energy costs of the different appliances. And they have some information from government. Well, okay, the government information, you know, it actually relates to some of these same appliances, but some of it not. They have consumer watchdog information. He's calling me up saying, Mom, isn't this an information integration problem? Can you solve this? Okay, how do I do this? He wrote a program to read stuff out of spreadsheets. I mean, there's no really good way to do this. A lot of it is handwork, and a lot of it is just, we have some machinery, but it's way too complicated to bring to bear on the lighter weight problems. Another kind of problem is that often the way that you solve the problem, that is, we do have some good techniques and technologies for integrating information, but which one is the best tool to use depends very much on what you're trying to accomplish. So here are two actually quite similar in database terms kinds of applications. That is, they're both what we would call online transaction processing sort of things. You want to go and do something against a database. But they have very different characteristics in terms of what people expect in terms of performance and availability, in terms of what they're looking for. I mean, you know, if the shopping site's down, it's really not the end of the world. I'd be a bit miffed, but I'll come back the next day. If my bank account, I can't get access to my bank account, I get a little more panicky, right? They have different things about currency of information. You have to give me absolutely accurate data on my bank account. But in fact, if you're 5% off on the price of something at the store, or if you tell me it's in stock and it's not, it's really not a big deal, right? And in fact, therefore, you can use very different approaches to how to bring the information together. And usually, when we naively talk about information integration, we don't take these kinds of characteristics and needs and requirements of the application into account. So very challenging in that regard. And then, as I also mentioned on that first slide, we have the problem that our users typically are really not experts in the data. They really don't want to be experts in the data. They certainly don't want to be IT experts and so on. They just want to know they want access to it, and they want to know what it means. And so there's this whole question of how do you enable users? Today, most of the information integration technology we have is okay to good for an IT staff to support. So, you know, you go to your trained guy, your database administrators and so on. We've got some good tools for them, but we can't help my son, right? Because he doesn't have an IT, he was the IT staff, right? But he's not at the level of sophistication where he could deal with this. How much less can we help, you know, scientists, researchers, doctors, and so on? We don't have the right level of tools for them. And if the answer has to be go hire an IT staff before you tackle this problem, we're not going to be able to solve it. So those are some of the things we struggle against that, you know, may be sort of obvious as I say them, But the other issue with integration that maybe isn't as commonly thought about is it's not just a thing you do. You don't just bring information together. It's a process. And it's a process that you go through over time, often periods of time, and that cycles, that iterates. So in fact, before you can integrate data, you have to understand what you've got. You have to understand where it is. You have to understand certain properties and values and so on. Then you kind of have to standardize it. You've got to understand when I bring it together, what do I want it to look like? How am I going to have a clean semantics? It can be something really simple. What's the right abbreviations to use? Or it can be defining a whole new terminology. It could be figuring out a schema so that your application program can run against it. So all different levels of standardization you have to think about. And how to handle those missing or inconsistent values often gets considered in that phase. Then you have to actually, I've said specify and then execute, but actually you have to decide how you're going to do the execution. How are you going to actually integrate the data? And depending on what you choose, you will now have to provide the inputs to that engine. So the engines themselves need instructions. And I'll make that a little more concrete in a minute. So you're going through this kind of process, and then you're going to eventually do this integration, see the results, and go, okay, good, good. And next week somebody will come in with a new requirement, and you're gonna start, trying to evolve things, or you're going to say, whoops, that wasn't what I wanted. Back to the drawing board. Where did I go wrong? And have to go iterating through. Yeah. Sure.
So it's a nice way of putting it. I've never seen integration put in terms of a process. It seems to me that we've always approached it as an ad hoc thing, that a messy thing. We've been at it now for
years.
As long as I've been in databases, and we're still talking about the very same examples, and we're far from solving them. So I'm hopeful that you describe it as a process. I just don't know how much of a...
Yeah, so we've made usually I get through this talk and I get about halfway into this talk and people get very depressed, especially researchers in information integration. So believe me, I wouldn't be here if I were depressed about this. We've done a ton of stuff, and I think as researchers there's a ton of really exciting challenges. Part of my hope is that in making us think about this in a different way, and for me, I started to think about this way in working in development and actually having to help people do an integration. But I'm hoping that will give people a framework to start to make progress on some of these problems. So bear with me a little bit. The color coding here is sort of incidental, but just for a little bit of context, if I look at kind of the research community and what we have done, starting to shift to that, in the red stuff, this execute, integrate part, you can think of this as a runtime process, right? This is how we actually do the integration. And our first generation of research was really focused on that. And we have made really good progress there. We know we have a lot of really powerful tools for doing integration, making it possible to actually access the data and making it possible to combine it in the kinds of powerful ways we want to be able to do so. What happened more recently as we got into a second generation of research, which is really concerned with the first three phases of this process, that the understand, standardize, specify phases, and we started to think about design time. We started to think about how do we make it easier to find the useful data, to prepare it to be integrated, to say what you want to do with it, and so on. And so that's sort of the second generation, if you will, of work. And we're still doing research in runtimes, and there's still good things to do there. We're still doing research in design time. There's a lot to be done there. But what I'm starting to see right now is a third generation of research starting to emerge, which I think is really exciting, but I don't know where it's going to lead yet, which is about how do you leverage and involve people in the process of doing the integration. And so some of you know, I've been going around preaching that we have to talk more to HCI people, those of us on the data side of the house, because they seem to understand people and social stuff and leveraging people. this is one of the motivations for that. So lots of beautiful results. There's a huge field of research. It's been, you know, when we first started playing with information integration, nobody really thought about it that much. In fact, back when Eliza was working with me on our STAR and distributed database, that was an integration project. We didn't think of it that way. But you know, we were way ahead of our time. Nobody knew or cared. And so it's really nice to see the field emerge. This is a very biased, you know, another view of this sort of areas of research where you can see in red, you know, some of the history or timeline around some of the, and this is, again, it's very biased, but some of the kinds of research that we did in these different areas. We started out with things like our STAR and distributed databases, multi-base, and so on. We did some work around, we kind of got disgruntled with that because nobody was ready for distributed systems really, and so there was or distributed databases anyway. And then we backed off and tried to integrate data by bringing it all into the database, and you get all these object relational projects and so on that went on. And then, you know, then we kind of stepped back and said, wait a minute, nobody's bringing it into the database. It's out there anyway. We got to reach it anyway. And we kind of went through a phase as a community of, okay, so how do we reach out to it where it is and still be able to provide powerful ways of manipulating it and accessing it. And it wasn't really till towards the tail end of the 90s that the serious database community started thinking about some of the design time kinds of aspects. There was actually very relevant work that had been going on for a long time on ontologies and semantics and so on, but the database community wasn't paying much attention to that. So when I say I'm biased, you know I'm leaving off a lot of research. This would be very much a database view of the world. And so we started to get into that, and it's only, you know, very recently that we start seeing people trying to leverage tags to help integrate and find the right stuff to use, or people's opinions as other ways of getting access to the data. And so I think that's just an emerging area. The dark blue stuff on this side, this is a very incomplete list of projects, but just the only point there is I didn't set out to do my career in information integration, but the blue projects are projects I've worked on, and somehow I seem to have sort of always done stuff in this space. Okay, so you said it very well. We're always looking at, you know, pieces of the problem, higgledy-piggledy. There are a lot of really cool research questions in each of these areas. And, you know, so really it's kind of like the blind man and the elephant. When you read a paper on information integration, you will find you have to ask yourself, what piece of the problem are they actually trying to solve? And that goes for my papers as well as anybody else's, right? What piece of the problem are they focusing on? Because it looks like a totally different beast depending which part of the problem you're focused on. And so what I feel like we're missing is the holistic view of the problem, and that's kind of what I've been trying to see if we can work more towards. Okay, so I don't know how many theoreticians we have in the audience, but I wanted to you know, now that I've kind of hopefully not depressed you too much, but posed the problem, I just give an example of some of the powerful results that we have been able to get in the field, and one of the things that we've done really nicely, I think, as a community is we've been able to define certain very nice integration problems and put a theoretical foundation to them, and so on. So we had this notion of mappings, and when the theoretical community got hold of that, so mappings is a way to relate two schemas together, because I was looking for an abstraction layer, and the theoretical community liked that. They defined two important problems, which we call data integration and data exchange. And the data integration problem says, you know, okay, we've got data in databases here. They're I1 and I2, and each of those databases conforms to a particular schema, so you could abstract the structure of the database and give it schema names. And the data integration problem you can then formally define as, given these schemas, given a global schema the way you want to be able to query this data, how do I convert a query on the global schema into queries on the underlying schemas? The other problem that came out of this is the data exchange problem. And that has more to do with transforming information. And you may say, what does this have to do with integration? But it turns out it's very deeply related. The data exchange problem says I have a database I. I know what schema it is, so I know how it's structured. So I have a source schema, S, for that database. I have a target schema, so I know how I want the data to be. How do I get a database J that that's derived from I and meets any of the constraints that are on J? So these sigmas are just sets of constraints that are on S, and T. So how that meets the constraints? And there are lots of other nice problems that got formalized, but I'm gonna focus on this data exchange for a moment and give an example of a very nice result here. So the result came from colleagues of mine, but I can't take any credit for this. They took this notion of the data exchange problem, and they formalized this framework based on this notion of a mapping between the schemas. And they said a mapping is a source schema, a target schema, and some constraints that, first of all, relate the source to the target, and secondly, say what the target looks like. And then there's a whole bunch of hocus pocus. But they asked themselves, given that mapping, if I have a source instance, you can tell I shouldn't use words like hocus pocus. The theory community gets very mad at me when I say that, but it's black magic to me. But okay, so they make a lot of conditions. There's some conditions on these things. And then they say, given that source instance I, how can I find the database instance J that I'm trying to create that satisfies these constraints? And so then they say, okay, obviously there can be an infinite number of these solutions, because I could always throw in some extra tuples that match the constraints, and they could come from nowhere. I can do various variations with things in here. How do I get the best, whatever the best solution is? Okay, and they were able to define the idea of a universal solution as one that's kind of more general than all the others, kind of standard, in my book, theory trick. And then they came up with this theorem. And their theorem says, okay, some obvious things. Give me this mapping. Then this universal solution, this best, most general solution exists only if and only if a solution exists at all, right? That makes sense. That's pretty obvious. But then they were able to prove that, in fact, figuring out whether the solution exists is in polynomial time. That means we can find a practical algorithm for generating the solution. So that was like really nice news. Furthermore, they had a notion of how to construct that, because the way you prove these things is you construct a way to do that. So they came up with this nice theoretical algorithm using something called the chase procedure, which kind of follows through constraints, starts with the data and starts following through the constraints, and it generates out your target instance J. Okay, so what's so beautiful? That's nice, but what's so beautiful? Well, it's beautiful for a number of reasons. First of all, it explains what's going on. So often if we can say concisely and nicely what the problem is we're trying to solve, we have a much better chance at arriving at a solution that actually solves our problem. And I know I talked to somebody in the privacy domain today that was sort of saying that, if we could say what we were trying to achieve with our solutions, then we'd have a better chance of knowing when we'd achieved that. Okay, that's obvious. The other thing that's nice is it kind of gave us a test, right? So now if somebody tells me that they have a great algorithm for generating this instance J, I can now test. I should get to the same J as I would if I used their theoretical procedure. So now I have a test of whether I've got good results, a good algorithm or not. But the best thing and the most beautiful thing about this is it turned out to be practical. And in fact, if you look at the mapping tools that we have that we built based on this whole line of research, it turns out we use that chase procedure. That is a really great algorithm. And so this theoretical algorithm went straight into product eventually, right? So through our research prototypes. So just to is just one example. It happens to be work that I really liked, but where research really has a lot to give to practice, just in case anybody was still wondering. That's why the theory, because most people think that's too far away. Okay, but the reality is pretty ugly. And so now what I want to do for a few minutes is just talk about what that reality really looked like. So what did I learn when I went down the hill to this SVL lab? And so you can see that popped up at the top there, and started to work with real customers on real problems. This picture, which probably is pretty confusing from back there, is famous in IBM. It is page 1 of 3 of one of our customers. It's an electronics, it's a company that sells, small electronics. This is a small portion of their data and application diagram. And this company is really an incredible company because they have a diagram like this. Okay? I won't tell you how long it took them to get this diagram. But each box there represents either a data source or an application. The lines are telling you some colored lines are telling you dependencies, others are telling you flow of data in the system. Most companies have no clue. They really have no clue. I've talked to customers who will tell me that whenever they sit down to design a new application, they assume they're going to have to create a new database or a new data repository for it because they will never be able to figure out which of the existing ones they could use. And that in doing that, they're now going to have to hunt and peck for where's the information going to come from because they don't always know. And they'll sometimes find it circular and have to go back in the process and clean it up. It's a mess. The real world out there is horrible. This is, we have customers with literally thousands of data sources. They have a lot of applications. There is no one individual who understands what's going on in these environments, right? So obviously I'm talking about the high end now. I'm not talking about my son and his hundreds of spreadsheets, but even in his case, he had hundreds of spreadsheets that he was trying to deal with, plus these government websites. So, who knows? Nobody knows. And then there's that part I talked about earlier where even when you've got a diagram like this and it captures the logical constraints, it captures the flow of information and the dependencies, it is not telling me about the other kinds of constraints. What kind of availability is this data source set up to provide? What kind of accuracy happened? What simplifications happen in this process? Did I actually aggregate some data and so on in there? And so it's very, very hard to really get a complete picture of your problem and what you're trying to do. So just to make this a little more concrete, let's talk a little bit about what does understanding mean, and I'm going to fly through this because it's a very simple toy example. But suppose two companies, I don't know why the other database, oh, there's the other database. Okay, two companies are merging, and the bluish stuff is from the small little company that is being acquired, and the nice green ordered database comes from the big company that's trying to buy it. And the first thing the big company wants to do with this new company it acquired is get to one single customer support center. So I need to be able to call one number and immediately, be able to look up any customer and be able to figure out what products they have and give them the right support, because otherwise it's just too confusing. And so, first thing they have to ask is, where's the customer information? And I know you can't read this, don't worry about it. But the idea is the yellow highlights are supposed to be customer information. It's scattered all over the place, right? And that's usually the first problem that people run into, especially with small companies, because they probably have been scrambling and they haven't been investing in cleaning things up. But even in large ones, you'll have trouble finding the right source of truth. Then they have to look at information quality and see is it complete or are there any duplicates. So in this case, ABC could be both a mail order customer and a web customer for Chico, that's the small company. And maybe they're also a customer of Grande, right? So we buy different things from different people and in different ways. And so I have different databases with representations of that company, and they're going to say different things about them. you'll want to know things about the statistical properties because, in fact, if you're bringing information together, one of the things you have to figure out is what data are you going to move. And so I need to at least know the size of the data volumes in different places. I have to have some sense of what us database people call the join cardinalities, right? I need to know whether it's going to be a restrictive query or a union or a what that's going to happen, and what's that going to do to my data sizes and so on. So I need to understand some things about that. I need to understand semantics, and this is a really hard problem, right? And in this case, I'm making it the impossible extreme case, but suppose that Chico, this little company, had you buy a warranty, like when you go into the Good Guys or whatever, and you buy a certain level of warranty service on things, and so their service level is related to that product and its warranty. Whereas Grande is more on the IBM model. We look at how much business you do with us, and the amount of support you get is proportional to the total dollar volume across all your purchases. Okay, so what does it even mean when a customer calls the same hotline, et cetera? And it maybe changes way outside the data systems that have to happen to do that, but somebody's got to understand and make some reasoned decisions about how we're going to do these sorts of things. Okay, and so on. And there's lots of tools. There's good news here, right? So you can go out there and you can buy tools that you can point at a database and it'll tell you the distributions of data and the different values and so on. There's a whole bunch of different things that we can bring to bear, but there are a lot of them, and that's going to be part of the issue, right? It's not really obvious where you start with these kinds of problems. Second phase of this process is standardizing the representation. And for that, we want to determine, how are we going to represent the information? And as I said earlier, this varies from really, really easy to simple little things. Like in Grande, it's a nice normalized schema, so we have separate fields for street, city, state, zip. Chico, they just put it all in a string somewhere because, after all, the only time they used the address was to ship somebody something and they wanted to print it out in a mailing label, so why look at it that way? It goes down to little decisions like, do I list customers' last name first, then first name, or did I list them first name, last name? I need to know and I need to decide how I want to represent it in the combined view, because otherwise my queries will never work. I won't ever find Elisa Bertino as my customer if I looked up, in one database it's really Bertino, Elisa. The string comparisons won't work, right? It won't come out right. Stupid little things, even smaller. How do I abbreviate street? Is it STR or is it ST? And if I have foreign addresses, all bets are off, right? So then what are the repair rules, right? I probably have totally different customer IDs. I may have different phone numbers for the same customer in two different data sources. Do I, list all numbers? Do I take the most recent number? I mean, there's lots of different rules. And today, people specify these rules by hand. They have to make a decision, and they kind of specify those by hand. Again, lots of good tools to help, but lots of tools, and they overlap. They do not, it's not like I use each of these in sequence and everything's fine. They're overlapping. Okay, so then, as I said, there's the specification and execution question. And we have a number of really good, very powerful techniques. I'm going to talk about three basic ones that are at three big spots in the spectrum today. One thing we know how to do is we know how to materialize data and put it in a warehouse. And there's the set of tools we call extract, transform, load, or ETL tools that you can go out and you can buy. And they know how to take data from a bunch of data sources, help you select the portion that you really care about, that's relevant. Sorry, doesn't do you any good if I point over there. And then, they have some script that they run, and out pops a database, and you can store the stuff. They know how to load a database, and then you can query it with whatever query language comes up there. The thing in the middle here is a data flow diagram for what this particular ETL job is going to do. and you don't have to worry about the details. This is actually a good tool. So the powerful tools let you actually sort of create your program, if you will, for what this process is going to do using a tool that does let you graphically lay things out. It's called data flow programming, and that's what they do. But a lot of tools, you just write a script. And the fallback position for this kind of thing is write a program. The program will have queries in it, and it'll take things out of databases and then load databases. So that's materialization. Materialization, there are a lot of different kinds of tools that do this, but materialization is great if you know how to specify the subset of the data that you're really going to use, and you're going to hit most of that data quite often. So it's worth extracting it once and putting it in one representation. It's because there's a fairly high cost with this. Where availability and performance are really big concerns. We know we care about it then because then you want to get the data all in one place so that you're not paying costs to go off and do lookups in real time and so on and so forth. And by making a copy, we hopefully have made it more available. Okay, good technique. The other technique, of course, or another technique that often gets used, and again, I did a lot of research in this area, is on how do you federate or virtualize your data sources. And this one, you say, okay, we've got a bunch of data, and we're not as sure, maybe, what data we're going to need eventually, or maybe it'll change over time. We need to be able to reach out to it in real time. We don't want to put it all in one system because it's not worth it to us. We're not sure we're going to need all of it. So let's leave it where it is and then give you the ability to ask really powerful queries over that data and in real time reach out and get the information. So this is kind of a nice approach. Again, if I don't know ahead of time all the data I'm going to need, and I think some things will be very rarely accessed, then I might not bother to bring them together. When I've got very heterogeneous data, as I tried to indicate here, it can be better because some of this data, face it, does not work really well inside a relational database, so don't try and stuff it into a relational database. It's often easier to get going. These are actually faster to set up, and then you can sort of try different things. And so there's a lot of really nice characteristics to it. But in other cases, it's really not a very good idea because you may get really crummy performance. It's very unpredictable whether a query is going to respond, even with the best systems we have, and we have some pretty good ones. You never really know whether you're going to get your answer in seconds or milliseconds or in hours. And so that kind of lack of guarantees, the fact that a site being down or a source being down may make the data unavailable, means it's not really for every application. The third point in the spectrum I was going to talk about quickly is search. And a lot of times people say, oh, Laura, search is not about integrating data, but I claim it is. It very much is. It just has really radically different properties than those other two solutions. Both of those two solutions let you ask a very precise query and get back a very precise answer. Search doesn't do that. It lets you give a very vague query and get back a ranked answer, some set of results which may or may not be what you're looking for. But I bet it's the most commonly used form of integration today. I bet most of you use this on a routine basis, and you don't think about it, but what are you really doing? You're bringing together data from, maybe all over the web, a lot of different data sources within, in my case, within my company, that I can get answers to with one keyword phrase. And heck, it's a lot quicker than writing a complicated query, jimmying things up to pull things together. And yeah, okay, so the results come back on 2 different web pages, and I have to manually think how they come together. But geez, I do that a lot faster than I write a program to extract it from the computer. So it's not the only way to view search, don't get me wrong. But it is one way to think about search and to think about the different characteristics and properties of this kind of application, right? I would not build either a warehouse or a federated query scenario if the only kinds of things I wanted to do was ask kind of high-level questions, and there's always going to be a person in the loop. So different environment, but still a way of doing integration. So what's the problem? The problem is that depending which of those 3 techniques I chose, I mean, it's great, we've got all this power, I have to specify what I wanted to do very differently. I might write a query, or I might write an actual program or a script or one of these data flow diagrams. I might throw down some keywords, very different. So once I've chosen how I'm going to do this integration, I'm somewhat stuck. If I make a mistake, I'm back to square one, and I have to kind of start over. That's one of the problems here. The other problem is that in reality, you never use just one of them. So again, a very fictitious but very simplified scenario. This is inside, we're looking inside Grande Corporation, and let's say it's a simple place. It has 2 divisions and corporate headquarters, and each division has its own financial applications. It runs its own business basically, but once a quarter, the company has to produce a quarterly report, and the headquarters have their financial apps, and they need to get data from each of the divisional databases into the form that they can produce their financial apps, okay? So that's their first task. Typically, you might want to solve that, since it's only happening once a quarter, with an ETL job. I define once and for all how this is going to happen. I know exactly what data I'm going to pull every single quarter from this place. I go through the pain, I write this program, I know how to generate the database they need. Then their horrible bookkeeping application that can run for hours and months and days, and I'm happy. It's not on my divisional systems and so on. It's very nice, very, very, very obvious sort of thing to do. But now let's think about how does Division 1 get its data for doing its financial apps? Well, it's got orders coming in. It's probably got an orders fulfillment database, and every time an order comes in, you might actually want to trickle feed that into your basic application, because now I'm managing the business. I want to see in real time if orders slowed down, if I've got a problem this month, if I've got a problem in a particular geo. I'm running reports constantly. So I need more accurate information, and so I might use replication, which kind of trickles things out. As a new order comes in over here, I propagate it over there to keep that up to date. The company probably also has a support application, and they probably, you know, in a good company, there's one number you call for support. My company has gone through various phases of this, but in a good world, you'd expect there'd be one number for support, and that from there will do some specialization and so on. And so the support guys, especially the level 1, as we call it, support, the guys who field the first queries, they have to know what customers are, what they're entitled to. And if a new customer comes in, if I buy something and I'm new, and you know, I then go home and try and install it, I want the support guys to be able to answer the phone and know who I am pretty fast. So again, we might be using replication to kind of keep for them a view of who the customers are. I'm probably not going to copy all the customer data, though, because you know, most of the time I don't need it, and I don't want to duplicate all that storage and try and keep it up to date in multiple places. I get into a lot of trouble there. So I'm only going to copy some very basic information. So then when a user calls in and I actually need some additional information, I might very well use federation to reach out and get that less frequently needed information and pull it back. Okay, fine. Now my customer calls in and they have a really hard problem, and what do they want to do? They want to know if anybody else has ever seen this thing before. Is there anything in my environment that has anything to do with it? And their default is fall back on search. You know, let me search the product things, the logs, the blogs, you know, from when internet, and see what's going on. So here I am, 4 of the many, many techniques for integration. Very simple toy example. Real world things are much more complicated. I already needed some combination of all of the above. The worst thing about this, is that there are not really good rules for where you use one or the other. I tried to kind of give you a feeling for when different things are useful, but in fact, it's not quantifiable today. We don't know. We don't have a theory or even just a costing structure or anything that will help us know how to choose between one and another. So this is the state of the art, and how do you choose whether to materialize or federate? Actually, it's worse than this, because I actually have two charts like this, and they say different things. But what is this? This was my technical sales lead when I was in development, and she was trying to tell her sales team which product to sell in what circumstances. And so it's a scale. It says, you know, lean towards ETL if you know you're going to have very large answer sets and response time's important and blah, blah, blah. And lean towards federated if you think you've got very volatile data and accuracy and currency are important and the requirements are just predictable and blah, blah, blah. But okay, usually you're in the middle somewhere. So where does this balance, and how do you know which pieces to use the different things for? It becomes a very difficult problem. It's a design problem that is not easy to understand. The other picture I show is it gives a line, and it says there's a spectrum of solutions between federation and materialize, and then it uses a different set of characteristics. That's the part that really upsets me to suggest what to choose. Okay. So I want to talk about products for a minute. So when I was in development, what was I working on? Yeah.
For a second before you go into products.
Sure.
It's interesting, you didn't talk about updates necessarily. So
no, so you're quite right. There is somewhere in the part it says if you're going to do a lot of updating, you know, and this kind, but that's the sort of thing that gets very messy very fast, right? Because I don't make multiple copies if I know I've got to propagate updates a lot. But you know what happens when some of these things conflict? Yeah, no. Right, I'm just simplifying the problem because I'm just assuming, you know, never mind, once I've got it integrated, all you're going to do is ask questions. But that's not the truth. Okay, so I worked on this brilliant thing we called information server. It was a great marketing story. It basically said, look, we're going to give you a platform for information integration. It's going to start with connectivity to a broad range of different sources of information. They could be databases, they could be applications, they could be content stores. We're going to give you access. You're going to have access to everything. And then we'll give you a framework where it'll have good performance because we'll give you a parallel processing framework. And it'll have metadata that it'll keep about all the data sources and the data and so on. And so you'll be able to populate this metadata store and refer to it. And that will help you. This notion of information about the data will help you with some of the pieces of this. And then we'll give you a set of tools. The set of tools will let you, guess what, understand, standardize, specify, and execute what you want to do. And so that sounds really good. It's just what I just told you. You need a process to do this, and you've got all the pieces. And then furthermore, no matter which of these tools you choose, you're going to be able to give me access. The deployment thing means, you know, okay, so you could deploy it as part of an application program that's accessing this thing, or you can do it as web services, or, you know, blah, blah, blah. So sounds great. Really good story. The analysts love it. The customers loved it. We are, you know, if you look at Gartner, you know, some of the other leading analysts, they will tell you IBM is the best, right? Their vision is terrific. They're executing to this vision. It's great. What does the reality look like? And don't quote me to an IBM salesperson. I'll get fired. Okay, this is the reality as of a little bit ago. I think we've changed some of the products and names, but I think this is more or less up to date. And again, don't worry, you can't read all this. What you're supposed to notice is that first of all, there's multiple products in every single one of the boxes, right? So it's not quite that simple. So which of those am I going to use? Those products overlap in various ways. Some of them have overlapping functions, some of them don't, and some of them are complementary. Some of them work with each other, some of them don't. We're working on fixing that. I think we will. Some of them work with the metadata server, some of them don't. The other thing that's kind of interesting is some of the same products pop up in multiple places. So that rational data architect can be used as a modeling tool to help you understand your data. It actually can also be used as a specification engine. So we let you do mappings in there, and we can generate out from that SQL queries if you happen to have chosen the federation approach to doing integration. Pretty cool. On the other hand, it doesn't let you generate out the right things for your data stage ETL, although we have another product that now uses mappings that lets you do that. Okay, and so on. So so you get the same product showing up multiple places. You can see that the execution engines over there, they all have their own specification capability. So again, once I chose an engine, I got a new way of saying what that engine should do. And so I can't just start things out in Federation and then move it to an ETL job, which is something that's very, very appealing to our customers, because it turns out Federation, as I said, is easier to set up and prototype and play with. And so it would be really neat if we could set it up, prototype, play with it, and then push a button and have the ETL job generated so that now we know we're doing the right thing. So when I show this to my development teams, they get very upset with me and very depressed. We've been working on all this time and we're doing all this stuff. And so then I always have to remind them, this is as good as it gets. I mean, they shouldn't feel bad at all. They should feel really good about life, because anybody else you talk to, they do not have an end-to-end solution. So at least we've got the pieces, and over time we know they'll get to work together more smoothly. We know where it needs to go. But it's a mess, and we don't even know how to bridge some of the gaps to get us to this end vision. Okay, so what do you take out of that? Well, this is the all right, so there's good research here. I convinced you. I hope it's a hard problem. I think we really have to focus as a community on simplifying this process. Applications today need information from multiple sources. It is very rare that there is a single point of truth that you can go to get the information you need to build whatever application you're going to do. And if you can go to one place to get that information, it is because somebody already integrated data from multiple sources for you. They already did that hard part. So I think this is the killer problem. Somebody asked me earlier, what are the important research problems? This is mine, okay? I think the way we do this is we need to go back to the principles, the basic principles that founded our field of data management, which is how do you raise the level of abstraction? How do we get people above the level of writing programs and give them the right level at which to reason about what it is they're trying to do? I think some of the keys to that are going to be leveraging semantics, more metadata, more information about information, and taking what we know about autonomics and compilers and compilation technology to generate more of what we need to do more automatically. So I think an unachievable goal that would still be really good for the community in terms of advancing where we're going is to try in our heads to think about non-procedural integration. So when we made the jump from normal hierarchical networked databases to relational, what was the key thing? It was the key insight was we could non-procedurally specify what it was we were trying to access. And then you could have a machine, what's come to be the relational database engine, actually do all the work of figuring out how to generate the complicated program that will actually do that. I think we have to try and do the same sort of thing in integration, and I think it's going to be harder because I don't think we know what are the pieces of the puzzle that have to be expressed. It turned out with relational database that a lot of what we needed to express, at least for the first round, were just logical constraints. But I think in integration we have to go beyond that. And so how do we get this complete high-level specification, I think, is a very important problem. But there are others. There's lots of things about how do you understand what data you've got, how do you standardize it, and so on. So I think there's a lot of good things for both the systems and theory communities to work on. And I've been trying to convince the various communities that's true. So just another thing about saying what it is you want to do, the specification problem. I think it's not enough to say we know how to logically specify what we want. SQL did that, right? Yeah, it sort of did. But it did it at a pretty low level in which you have to know the names of the tables and the columns that you want to get things out of. So how can we raise that to where the user can start expressing more amorphous needs? I want the customer information in my database. Can we figure out what the customer information is? Can we, and what kinds of tools and so on do we need for that? And that's something we've been working on a little bit at Almaden of late. Sure.
Kayak and orbits, they integrate many airfares.
Mm-hmm.
Are they getting the data in a uniform format from the airlines, or are they integrating the data?
I don't know about orbits in particular. I know there are some companies that have made deals, and so they can actually, like get extracts of information, and on a regular basis. But a lot of things are actually having to hand program in how to access and ask questions of their partners or not so partners back-end data sources. So it really. There is a spectrum. I mean, if you trusted orbits, and you're American Airlines, you can choose to share with them a digested module every night of your database, and maybe that's enough, right? Until they go to book it, and even then, you've got to kind of hand program the stuff. Most of it's hand programming, at least at some point. Okay, SQL queries are impossible for people to write. So, that's what we found is normal mortals can't write SQL. And so another thing you can look at in terms of logical specifications, how do you even say what you want? And that's where the search motif comes in, right? It's very tempting to just give a few keywords. We all know how to do that. There must be a middle ground that's kind of more useful that way. We're sort of running out of time. Yep. You got the punchline anyway. What metadata do we need to support this, and so on. And then there are these practical properties, and those are really puzzling because we know that choosing how you're going to do this has a lot to do with what are the qualities of service I need out of the system, what do I need in terms of quality of the data, what are my physical constraints, what policies are there. One of the reasons federated gets used a lot in Europe is because, in fact, they can't permanently move a copy of data across certain country boundaries, right? Countries have privacy rules about that, and so their hands are tied. So there's all sorts of crazy things like that that have to be dealt with. And then, we'll skip the formal issues, sorry, in the interest of time. But, I've started to think about, well, what are some of the systems issues that we want to get into? And each of these by itself is a good problem. How do we automate this process of finding the metadata we need, of discovering what information is out there? How do we specify what we want from the system? What kinds of tools do we need? How does this thing look like? Can we build, once we know what we're trying to do, can we build an advisor? Can we actually do a compiler that could generate all the stuff that we need to do? How do we help people do that? And then there's the question of, what is the integration engine itself? Is it one engine? Or should there be actually can we think of it as blades, a set of engines that are used for different purposes, and you know how to invoke each of them? If it's one engine, can we build a super engine that does everything? And then, of course, there's all the, usual system stuff, like how do I make it simple and yet able to meet a range of requirements? So we're working towards this in IBM, and I can talk more about detailed problems. We don't have anything looking at anywhere near the overall solution yet. People are still sort of looking for shortcuts or looking at, in a Web 2.0 world, is there an easier way to do this, and so on. I see pieces of work as I go around the world and talk to IBMers and colleagues from academia and other labs that give me hope, really cool, exciting stuff. But there isn't really a solution yet. I don't think there'll really be a full solution in my lifetime, but I think we can do another huge step forward. Never mind. Okay. So that's basically what I wanted to say. And what I've tried to tell you today is that there's a really hard problem here, and I guess what I'm asking is, can beauty, can research really tame this beast of a real-world problem? I hope I've convinced you that it is a hard problem. We've only looked at aspects of this big picture. There's lots of work to do still on each of the individual aspects, but I think also we need to understand the problem.